Hello and welcome to the next video in the series covering reaction stoichiometry. In this video we're given grams of one substance and we need to calculate grams of a different substance. In this video we'll look at method B. Alright, and we do have method A, B, and C for this type of problem. We hope you'll visit and view the other videos as well. In a separate video we learned what the chemical reaction, the balanced chemical reaction, looks like for this setup for propane burning in air. And it is C3H8 plus O2 gives CO2 and H2O for complete combustion. I balanced the carbons first, the hydrogens second, and then the oxygens. Alright, looking at method B. For method B, we're going to, as with the other methods, we're going to write what we're given, 92.6 grams of the propane and X grams of the O2. Alright, and for method B, the next thing is that we're so familiar with the method A, or doing this kind of problem, we know that the first step is to get to moles. And we know that to get to moles, we take the grams and we divide by molecular weight. So I calculated the molecular weight ahead of time, and I know that it's 44.11 grams per mole. Now, when I divide those two numbers, I get the moles, and the calculator gives me a lot of numbers. I don't want to lose any of those numbers. I don't necessarily want to write down all those numbers either. So I write at least 5 is my rule of thumb. But I keep them all in the calculator and don't round. So now I have the moles. Now I can use the ratios. So I know from the balanced chemical equation that 5 moles of O2 matches up with 1 mole of C3H8. So now I want to know how many moles, I could use that as X or a question mark, I'll go ahead and use X, moles of O2 for 2.099297, etc. moles. I don't have room to write it out to the right, so I'll just squeeze it in down here. Moles C3H8. Now I cross multiply and I get my X to be 10.4964, etc., etc., etc. moles of O2. Again, I'm not rounding, I'm leaving that number in my calculator. Now that X is not my answer yet. My answer wants the grams. So to get from moles to grams, I multiply by, that's a times now, by molecular weight. So 32.00 grams for 1 mole, and that's O2. So then I get my answer to be 336 grams of O2 needed. So again, in order to do this kind of problem, we recognize that the given grams need to be converted to moles by dividing by molecular weight. Then we can set up our ratio and then convert back to grams of O2 by using oxygen's molecular weight. Alright, our next video will look at method C, which is a little bit different. Again, you get to choose which method works best for you. I hope you'll join us for the next video.